Hey, AP Chemsters, this is Mrs. Vanderwey. I hope you had a really nice break. I know that I did. And now that you're ready to think about chemistry again, hopefully you remember what we had said earlier, where our goal was to have you actually read the book and follow along with your notes, and then use this blank wall video more as a reinforcement. I will be using each section as a separate a video. So if you'd like to read ahead, do your notes, and then watch the blank walls that are coming up, you can do that. Or if you read it all at once and then did your problems, then this is more of your review, if you will. So section 9.5 starts off with covalent bonding. You should have remembered what covalent bonding and Lewis structures were from your first year chemistry class. Covalent bonding occurs between two nonmetals by sharing their electrons. Nonmetals, if you remember, have high electronegativities, high electron affinities, very low ionization energies, meaning that nonmetals are going to gain electrons. And how can two nonmetals both achieve the stability of a full octet? They do it by sharing. So we're talking about single covalent bonds here. And in order to understand these, we need to go back to our valence electrons and what the Lewis dot diagrams are showing. So it says write the Lewis dot for hydrogen and for oxygen. If you remember, you have to go back and see, oh, hydrogen has 1 valence and oxygen has 6. So go ahead and fill those in if you haven't done so already. If you have ever had me, you might remember how much I love my smartboard. My oxygen looks kind of funky, even though I did sync it before we started. But anyway, hydrogen has 1 dot and oxygen has 6. So our formula for water, H2O, will have the oxygen 6 valence electrons and the hydrogen's 1. And it says explain why the formula requires 2 H's and 1 O. That's the only way that oxygen is going to achieve its 8 electrons, its 8 outer electrons, like the noble gases would, and hydrogen will have 2, the way helium does. So it says hydrogen gets 2 electrons around it, called a duet. Well, duet means 2, and hydrogen only wants 2, and there are many reasons why. First of all, helium, its noble gas partner, will only have 2 electrons. The only shell available for hydrogen is the 1s shell, which can only hold 2 electrons. Oxygen gets an 8th electron around it, called an octet. And why is that? Because it will now have a filled second shell. So the S and the P added together will give it 8 electrons. If you look at its nearest noble gas neighbor, it's neon, and neon has 8 valence electrons. So it says, look at the Lewis dot diagram again for water. The bonding pair is the shared pair of electrons, showing here and here, and I believe your notes have that. And the lone pair are the electrons on the top and on the bottom, in this case of oxygen, that are not involved in bonding. And then it says a structural form is where, quote, sticks, this dash, replaces the 2 shared electrons. So if you look at your Lewis dot, you will see where here's oxygen, and I'm going to replace these 2 electrons up here with these dashes. Those are your 2 electrons. I'll put the hydrogens here, and then don't forget you put your lone pairs back in. So that will be a structural formula. That's probably a lot more common to draw as you really get into these more often. But it's always good to start off with a Lewis dot diagram so you can see where the bonding takes place. So it says, problem number 10, write the Lewis dot diagram and the structural formula for hydrogen and chlorine. So why don't we go ahead and do that. If you add up the hydrogen's valence electrons, you get a total of, well, 1 plus 1 is 2. So you only have 2 electrons. So it will look like this. There's your 2 bonding electrons. And if you want to do a structural, we're going to place those 2 electrons with a dash. Chlorine has 7 valence electrons, and so each chlorine is 7 plus 7 is 14 electrons. Yes, 14 electrons to play with. So let's start off here. And so there's 2, and I'm going to place the other 12 around chlorine that way. And if you add them up, there is 14 electrons, which is exactly what we want. You notice we have 2 dots between the chlorines. There's your single covalent bond. So I can draw my structural formula. And now don't forget the lone pairs. Okay. And it says, are all diatomic elements, remember those are your Hofbrinkels, by the way, hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, chlorine, are they all single bonded? And so it says, let's try oxygen. All right, so let's try this. Oxygen has 6, so I have a total of 12 electrons. Ready? So here's my oxygen. I need to create my bond, and now that I used up 2, I have 10 electrons left. All right, so here we go. Well, that didn't work out too well. Let me try it again. All right, I still have 10 electrons, so I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, that's not too good. The right-hand oxygen is missing 2 electrons. It does not have an octet. What's wrong with these guys? These all have 7 electrons around them. That's not an octet. I don't know how I can draw oxygen as a single covalent bond and still have each oxygen with an octet. So that brings us to our next form, which is the double and triple covalent bonds. Basically, if single bonds don't work, try double. If double bonds don't work, try triple. If none of those work, you may probably have made a mistake. So let's try this out. You probably could not have gotten the oxygen to work out. That is very true. So instead, try double bonds. So here we go. Here's 4 electrons. That's a double bond. And so 12 minus 4, that's 8. So I need to use 8 electrons. Well, let's use some symmetry here. 1, 2, 3, 4. 1, 2, 3, 4. Now go back and check. Do I have 12 electrons? 2, 4, 6, 8, 10, 12. Yes, I do. And watch what else happens. 8 electrons and 8 electrons. Both oxygens have a full octet. That's good news for oxygen. All right, so here we go. So because oxygen had the double bond, that worked out perfectly. So here's the moral of Lewis dot diagrams. If your single bonds don't work, try double. Double bonds don't work, try triple. If triple bonds don't work, you probably made a mistake. You're going to see a few exceptions later on. So let's draw the Lewis diagrams for the following. So with nitrogen, nitrogen each has 5 valence electrons. So we have a total of 10 electrons to play with. All right, so let's try this. Let's try double bonds. So I just used up 4. I need 6 to go. 1, 2, 3, 1, 2, 3. I have 10 electrons, but you know what? Each nitrogen does not have 8 electrons. So double bonds didn't work out too well. Let's try triple bonds. Okay, that's 6. I only have 4 more to go. I'll give each nitrogen 2. And voila, look what happens. 8 around nitrogen and 8 around nitrogen. That worked out really well. What about the next one, H3O+? What does that plus mean? If you have a +1 charge, that means it lost an electron. So if I add up all the electrons, let's see here, I have 3 from the hydrogens plus 6 makes 9, subtract 1, that gets me 8. I only have 8 electrons to play with. So here's oxygen. Let's do this. And let's see here, 2, 4, 6, there's 6 electrons there, and I'll have 2 more, and there we go. There's my 8 electrons. Now, if you ever have a charged ion here, you must put them in brackets and then put the charge on the outside. If you ever have a negative, you need to add an electron, put brackets around it, and put a negative on the outside. Let's try the next one. That's H2O2. Well, let's add up its total electrons. So I have 2 from the hydrogens, 12 from the 2 oxygens, so I have 14 electrons to play with. Well, if you haven't guessed this, nature does prefer symmetry. So I'll put the 2 O's in the middle because I can have multiple bonds with oxygen. I cannot with a hydrogen. So there's that. And let's put the hydrogens in. Again, nature does prefer symmetry. And so now I've used up 6 electrons. And let's see here. I had, 14, used up 6. I have 8 more to go. So let's check this out. 1, 2, 3, 4, 5, 6, 7, 8. Does that fulfill what we're looking for? Does each oxygen have 8 around it? It looks to me that way. How about hydrogen? Remember what we said about hydrogen? It can only have a duet. There's my 2, and there's my 2. So the Lewis structure has been fulfilled. So now what? Problem number 12. What is wrong with the following statement? Atoms for bonds in order to satisfy the octet rule. Well, do all atoms bond to satisfy the octet rule? Well, we've seen right above that hydrogen does not. Hydrogen only wants 2. Other than that, that is probably the best arrangement is to get the octet. We're going to see a little bit later on that not every atom will always have, besides hydrogen, that is 8 electrons. We can actually expand that octet later on. But for right now, our best answer is no, hydrogen only wants 2. So that concludes section 9.5. I hope that helped, and stay tuned for 9.6.